Hello, hi guys. In this video, I am going to show you how you can calculate the water delineation from the dam data of your required area of interest. So first you need the dam data. Uh, uh, first go over the earth data website and go over the earthdata.nasa.gov and go to find data. Okay, first you log into the earth data. i have uh, I have already logged into the earth data, so it directly redirect to the page. But using the if you are not using the earth data yet, you need to register here and log in and go over the platform and go over the okay, select the mm, platform and view all. Okay, uh, go over the allos and select okay, and drag and drop the map and zoom your required area of interest. Yeah, I am from the Nepal. I am from Nepal, and I uh, select the Pokhara, select area of Pokhara. Yeah, that's it. And go over the LS pulsar at a high resolution. Select over it. Select it. Okay. There are the five dam available for this area, and you download the dam based on the required date. That's it. I have already downloaded the you can download from here. I have already downloaded the dam data. So I go over the uh, um, ArcGIS and edit the dam data in the ArcGIS. So first of all, go to the folder connection and connect to your folder. I have already connected to the folder where the dam data is located. It's inside the new folder. uh, uh, its name dem.lyr. In your data set, it is in the form of .tiff. So go to the properties. This step is only for me because I had already set it to the 90% transparency, and that's all. And your required area of interest, your downloaded name has the large spatial extent, so you need to clip the dam for your required area of interest. But I have the required area of interest is much less than that. Okay, due to it's so the uh, coordinate transformation conflict. Simply close it. Yes, this is the my required area of interest. Go over the table of content. Okay, and see. Okay, first go over the art toolbox. Okay, and go to the data management tool and go over raster and simply click over raster processing. Okay, simply click to the clip, and input raster is simply okay. Input raster is DM, and the output extent is your required area of interest. I have the Ward 16 of Pokhara metropolitan city, and you can hide or so the help of the field. Okay, simply check over do those 2 points, and select the output location. I simply leave as it is as a default. Okay, select over OK and wait for some minute. Okay, it take more time than that of usual. Okay, yeah, it clipped over the area and return the dam value, only dam value of the dam value only to that of the required area. Okay, simply remove this value, remove. Okay, we get the proper data sets. uh, uh, so that so that we need to start from this point. Okay, and we have the we are going to calculating the watershed. The watershed and area that drains the surface water to common outlet, that you may know that. Okay, all of those points describe about the watersheds. You can also read and understand those points. Okay, uh, the methods, the steps required to calculate the watershed delineations are at those. So we start from the field dam or the elevation raster is the wider is the wide of depression. Okay, you can also see those void or the depression in this dam. uh, the water in the 30 pixels, uh, it does not get any direction to outlet. So this is the some of the depression are the real, such as the queries, but are the some of them are the imperfections. Most of them are imperfections, so we must need to remove those bytes from the raster data set by applying the field name. So the common method of the removing the depression is to increase its cell value to the lowest overflow point. So the lowest value is the 35. 35, so 30 value is converted to the 36 using the field name. Now go to the ArcGIS and the Arc toolbox, and the Arc toolbox, go to the spatial analysis tool, and go to the hydrology. First of all, click over field. Okay, input raster, dam clip, and if we are interested to change the locations and keep all those file in the folders, you can select from here, folder from here, but I leave as it is. And you can set the z limits, uh, the meanings of the z limits from you can see from here by clicking the so help. I simply click OK. Okay, the raster getting processing processed. and we get the required rasters, fill names, and it is the perfect for the watershed delineation. And simply remove this layer, fill them, simply remove this layer. Yeah, go over the arc toolbox and fill. And the second step is flow direction. flow direction the flow direction defines the flow direction shows the direction of the water flow from here. And okay, flow out of the each cell. The 67 the water in the 67 pixel flow either in flow in the steepest slope. This can be the widely used method for the deriving the flow direction is D8 method. The D8 method uh, the D8 method the D8 method assigns the cell flow direction to the one of its eight surrounding cell that has the steepest distance. Yeah, I already said that. This can be done by the steepest slope can be calculated by uh, difference by difference by calculating the difference between the neighboring cells or by the immediate cells or in the corner cells. But one difference is that the corner cell is divided by x root under 2, uh, uh, so that the steepest slope here, although the difference between 67 and the 40 is high, but it is higher. The water in the 67 is flow toward the 52. This can be shown by the D8 methods. In the ArcGIS, if the water in the cell flow towards this cell, then the in the center cell the value is assigned to 1. If it in this direction, then it is 2. Then it if in this, then 4, 8, 16, 32. You can also visualize it in the map. Let's go to the okay, ArcGIS arc map. Go to the arc toolbox and select the flow direction. Input surface raster, fill them. And you can, if you check over, the force all is to the flow onward, the on outward from air cells to the outward. And then it force all the cells to flow outward. But if you unselect it, then it doesn't do anything in the raster. I simply leave unchecked and select click OK. Yeah. Okay, table of content. Yeah, I said that the okay. Let me explain something more. The raster in this cell. Okay, the water in this pixel flow towards this direction, because uh, the value assigned to it is 2. You can also see in this layer. So if the pixel value is assigned to 2, then the flow direction of the raster is in this direction. Okay, go over the earth map and table of content part 16, zoom to layer. Okay. Okay, then another step is to flow direction and calculate the flow accumulation. Okay, flow accumulation means flow accumulation. Flow accumulation raster tabulates for each cell the number of the cell that will flow to it. Okay, in the flow direction raster, we get the raster having value to 1 to 4, 8, 16, 30 to 64, 128. This is the flow direction raster. If the flow direction raster had assigned the value to the two, then it is then the direction of the flow of the water from this pixel is in this direction. If the flow is in the direction, I had already shown this process in this figure. So we have the the flow accumulation calculates the how many numbers of the pixels water of the pixels flow in such a pixel. In this pixel there are no any pixels water is flow towards this but if you look at this pixel uh, the pixel value having 2 and the 4, this pixel and this pixel flow towards this pixel, so it is value assigned to the 2, like that. uh, all of the pixels flow towards certain direction, and this is the if the pixel value if the flow accumulation is 0, then it is called the ridge line, and if the flow accumulation value is high, then it is called the streamline. Okay. uh, go over the again go over the ArcGIS and go to the flow direction, and we have to calculate the flow accumulation. Okay. Calculate the input flow direction raster. Okay. Flow accumulation from the synthetic. Okay. Yeah, this one is the flow accumulation raster. Flow accumulation, we get the flow accumulation raster. Now, the third step is to applying the sum condition in the flow accumulation raster. Okay, I have already said you that the in the flow accumulation raster, if the value is 0 or the 1 or 2, only 2 are the small such small values, then it is called the then it's called the ridge line, or the hilly areas. But if the accumulation value is higher, in the large rasters, the value accumulation value is very high, so that we have to so that the we have to calculate the here we calculate the water delineation. So those pixels having the high value of the flow accumulation is responsible to calculate the ridge line or the streamline. Sorry, no ridge line, streamline. So we set the threshold value, certain threshold value, and we only takes the only takes the pixel having the high value of accumulation. Let's see it on the arc map. Go to the arc toolbox and go to the conditional, and go to the and input conditional raster. We have to provide the flow accumulation, and if the flow accumulation value is VAL, so in the so help, I always use the documentation to such a process. Value is if the value is greater than 400. If the flow accumulation value is more than that of 400, it takes the value of flow direction. It takes the value of the flow direction. And if the flow accumulation value is less than that of the 400, it simply leave all those flow direction value. You can also visualize in the map. uh, let's process it. Okay. We use the threshold value of 400 for the flow accumulation. Okay, simply click OK. Yeah. mm, Again, we have also applied the conditional raster, and go to the and another step is the apply some kind, and go to the stream order. uh, Stream order separates the okay stream order separates the streamlines based on their accumulation value, or the you can also think like it separates the class. If the flow accumulation value is 400 to 1000, then it classified by on the one class, and 1000 2000 another class, 2000 to 4000 another class, and like that, like in this order. We have the highest flow accumulation value is equal to that of 110 100 44,000. Yeah. We have the also we got the conditional raster. Go to the again, we have to calculate the stream order. Input stream raster, conditional raster here, and input the flow direction raster from here, flow direction. Okay. Go to the stream order. Okay, click over the okay stream order. Yeah, I got the stream order. Act toolbox. Toolbox. Simply uncheck all over it. Yeah, all those are in the raster format. These are the pixels, but while calculating the while designing the watershed delineation, we need those delineation in the vector format. So another step is to stream to feature. Input the stream order stream raster. Okay, flow direction raster. Apply the flow direction raster and simplify polygon. Okay, the stream features. Yeah, we got the value. Simply table of content. Stream to feature. Leave those value. Okay, let me increase the width of boundary and go to the table of content and stream order. Go to the properties and symbology categories and grid code. Let me visualize the grid code. Open attribute table. Grid code values varies from the 1 to 3. Okay, 1 to 3. Okay, table of content. Go to the stream order. Okay, and categories. Grid code and add all values. Okay, 1 to 3. It and simply click OK and OK and go to the 1 and provide to the 1. Okay, that's it 1.5. Okay, and 3 okay 2. Okay, yeah, this is the watershed delineation. And at last, we always need a if we are uh, going to design a dam in this place, and we are going if we are going to designing the drainage in such area, we need to know the about the how much water is flow towards such a point. So this can be calculated by using the watershed. There are two types of calculating the watershed: area wide watershed, and the point wide watershed. uh, I show you the point wide watershed. You can in the similar way you can use the area wide watershed. Okay, go to this Arcgis and catalog, and here I have the demo. Okay, this can be prepared by go to simply and go to the new and save file point and go to the edit and projected coordinate system. Provide your on a projected system of this data northern hemisphere. This is in the 44n. Okay, save file. Okay, news about this. I have provided. I rename it to the demo and editor. Go to the start editing. Go to the demo. Okay, and go to the create feature. Simply click demo and simply click point and click to the point and okay, I select this point, but I need only one point. I need to calculate the watershed of this point. So go to the table of content, demo on attribute table, and select this point and simply remove it. Okay, editor, stop editing. Do you want to save? Yeah, why not? Go. I need to calculate the water sheet of this area. So go to the toolbox and water sheet flow direction raster. Okay, I have to provide the flow direction raster. Flow direction. Okay. Okay, feature point or the feature area. We have to provide the feature area from here. This rename is demo. If I have the multiple points and it calculates the value for the multiple points. That's simple. Okay, simply click to the okay. It process getting processed. Yeah. Uh, the water of all those area is collected in this point. If we have the rainfall data, then we can easily calculate the how much area, how much water is collected at this point. That's it. That's all for the watershed delineation. Watershed delineation. Mm, that's it. Thank you.